Good morning, and welcome to the In a Breached World webinar, where we will talk about authentication and trust. With that, I'm pleased to turn the call over to your hosts today, Andras Chair, Vice President and Principal Analyst at Forrester, and Ryan Wilk, Vice President of Customer Success at New Data Security, a MasterCard company. Andras, please go ahead.
Thank you. It's a pleasure to speak for this webinar. And today, I'm going to talk about how we are able to mitigate some of these breaches, how we are able to actually avoid these breaches, talk about some of the password data, some of the password implications, and the need to kind of move away from passwords, talk about basically functionality, friction, and less fraud. Also look at biometrics, biometric authentication, as well as risk-based, and finally behavioral or passive biometrics. Make a comparison between really desktop and old school versus biometric authentication and behavioral biometrics, and then finish off on some recommendations and predictions here. So with that, let's dive in. I really take a ton of inquiries on this topic, and we see customers really asking us about passwords, really putting a drain and really a strain on your budget. Obviously, passwords are difficult for customers and consumers. Anything that is of length that anybody can remember is really easy to crack. So just for this reference, a 6 or 8 character password without any difficulty, without any uppercase, lowercase, special characters can take anywhere between 1 to 2 seconds to crack. So, and this is really on just basic equipment. Costs are really high in terms of passwords because we have to take password reset calls or password-related calls in the help desk. So really 20 to 30% of these calls are help desk related in the cost. It can be about $31 basically resolving these password-related issues. And then we've seen a lot of organizations spending somewhere between $150, $200 per user per year to resolve password-related costs. So this is, again, a huge, huge drain on budgets and really a big inconvenience. But not only does the enterprise or basically the service provider take costs when dealing with passwords, but you also have to look at the customer experience, right? So passwords are long and really hard to remember, and then they cause lockouts. When somebody gets logged out, they have to actually unlock the password. A lot of customers want seamless access to their accounts, right? They'll take their business elsewhere if the login friction is too high, right? So we did a survey and we asked around and wanted to see what percentage of shopping cart abandonments occur at login. And we got a staggeringly high 37.4%. So well over 2/3 of the shopping cart abandonments occur at login. It's really something that you have to pay attention to. 40% of U.S.-based online retail professionals cite as a significant cause of cart abandonment lengthy and complicated checkout forms, right? And really that is, in that we include really heavy authentication protocols as well. And finally, 57% of U.S.-based online retail professionals believe that improving the user experience will ultimately improve conversion rates and revenue at checkout. So it is in everybody's best interest, right? And if you want to grow revenue, it is in your company's best interest to actually provide a good authentication and security experience here. Obviously, a lot of organizations are talking about this. Basically, the less friction you have, the less fraud you have, the more functionality you have, and the more innovation you're able to do. So locking out the bad guys, making sure you have less fraud, more security is very important. Providing less friction or causing less friction for the consumer is absolutely something that you have to do, because otherwise they'll go someplace else. And providing more functionality, fewer false positives, lower cost of handling all this, again, is a very important aspect here. So how do we do this? What are some of the trends that we see in this market? layered and as-needed biometrics have been taking center stage, right? So obviously, you need to augment passwords with some level of biometrics. And then layer, when needed, two-factor authentication or 2FA biometrics for out-of-band support on even mobile devices is very important. So as mobile devices and mobile-first development become center stage, you have to realize that you cannot really deliver one-time passwords to mobile phones via email or SMS text messages. You have to do this out of band somehow. So do it in another channel. Use another channel for authentication than the phone, than just these OTPs or passwords. What really happened in response to this is we see basically fingerprint pushed by the Apple Touch ID or the Galaxy S5 and above fingerprint readers, Apple's Face ID on the facial recognition side of things, and really using the microphone really on mobile devices to process voice prints and voice authentication. The reliability of all these algorithms, especially voice print and others, have been exponentially improving. And really, it's all good. And in addition to these elements, we also see organizations looking at device fingerprints or reputations gaining ground. So that is something that proves or disproves whether the device has actually been involved with fraudulent activity, or is the device a known good device. So how does device fingerprinting, or we call it risk-based authentication, work, right? This is another building block of creating a seamless and very usable implicit customer experience. So really on the left-hand side, you need to look at the authentication context or even pre-authentication context, such as user identity. Has this identity username been seen maybe 10 minutes ago logging in from a completely different geography, thousands of miles or kilometers away, and now logging in from our location? In this case, impossible travel might be very well in the picture. So the user could not have moved thousands of miles in a matter of minutes. So that is always implausible velocity, or too much travel is always an important thing to track. IP address geolocation, definitely an important aspect. Trying to understand what IP addresses are being used for login activity. Is this a rogue IP address? Is this a kiosk? Is this something that is on a mobile network, etc.? Then a device fingerprint, which is what I talked about on the previous slide, creating a unique device identifier being formed of things like of screen resolution, or being formed of some IP address characteristics, or installed fonts or installed software on the device, which basically creates a largely immutable device fingerprint that you can look at. So even if a fraudster is using multiple usernames to try to log in from the same device, or trying to fraudulently register or enroll in service, you will see that in fact all these requests are coming from the same mobile device or desktop. Session speed, again, is a very important characteristic here in the context. If you're seeing people, human beings interacting with a website, you're going to see people actually reading pages, right? So it takes 5-10 seconds between changing pages. If you have robotic activity, bots or botnets trying to scrape websites or commit fraud or account takeover, you're going to see basically sessions speeds ranging between clicks in the tens to a few hundreds of milliseconds, which is clearly not something that anybody can actually read a page. And finally, a time of the day, right? What time the request is coming in? Is it normal and customary for a user to log in during that period of time? So with all these authentication context variables, you can create a risk score, and if a risk score is high, then and only then you may be able to ask for things like security question and answer, hardware token, software token, mobile token, send a text message or an email with a one-time password, or use some kind of biometrics. One issue, right, with this, so this looks all good, and this has been in production, and we've seen risk-based authentication in the past, is what happens if the device is compromised, right? So the problem with this approach is that if there is malware or robots or some really unintended activity going on the endpoint, the device identity, session speed, user, all this will check out fine, but you might still have a taken over or compromised device. So how can you solve this problem? Well, if you look at the authentication flow, right, typically we've seen people using passwords. That's the what you know aspect or factor, right? And in multi-factor authentication, what you know is one factor. These are typically passwords. The what you have, these one-time password tokens, device, text messages, context, these are basically the what you have factors. Then you have the who you are, legacy biometrics such as fingerprint or facial print type of biometrics. These are all good. But again, these all may be fooled, and they're only looking at a short period of time of authentication. You make a decision, which is a one-time decision, and after that decision has been made, green, allow the user to log in, or red, lock the user out or keep the user out, and disallow the user to log in. There's no change in the decision. So what it would be really nice if there was an additional factor, which is the what you do factor, right? And this is where behavioral biometrics enter the picture. We see behavioral biometrics and voice biometrics enter this space. And this is really about understanding whether it is the user who's actually interacting with the session. Is it really the user, or is it a robotic piece of activity? So behavioral biometrics or passive biometrics or continuous authentication, they all tend to refer to the same thing. They really look at a lot of the following parameters. So the objective of using behavioral and passive biometrics is really seeing the user behind the device. What this boils down to is to really understanding, is this Andras chair interacting with the device, or is it somebody else? Is it a robot or a different human being? So what are some of the factors that you can look at in behavioral biometrics? Well, you can look at the typing speed and pattern, how you actually type on an on-screen keyboard or a real keyboard. You can look at mouse movements, how I move the mouse versus how somebody else moves the mouse. There's going to be differences. In a lot of cases, robots basically tend to just move the mouse on straight lines in a very geometric shapes. Screen swipes, how you touch the screen, and also the force of touch on the screen if you have a 3D touch sensor, but really the patterns, how you move your finger on a screen. And then really you can look at things along the lines of how you change between fields. Are you using the mouse? Are you using the keyboard? Are you using the tab keys? Clicking, how you click on things, etc. And looking at accelerometer data, how you hold the device actually can be indicative of a normal or authorized user versus a fraudster. And really getting all this information pre-authentication and post-authentication to play is very important. So this is, again, as I said, not a one-time authentication, pre-authentication decision, but also a post-authentication or continuous authentication decision where you're continually looking at these variables and behaviors and continually actually comparing them with a known good baseline. So let's take a look at how traditional biometrics and behavioral biometrics are different, right? So if on the left-hand side there's the aspects, and then in the first column the traditional biometrics, and the second column you see behavioral biometrics. So the authentication sample for traditional biometrics is usually a static thing. It's a fingerprint, facial print, etc. In behavioral biometrics, it's more of a built and dynamic sample. So it's a little bit more complex to set up an authentication sample, and it takes a little bit longer. One-time versus continuous authentication, typically, as I said, biometrics biometrics, traditional biometrics offer a one-time authentication, usually very little risk score. Continuous authentication and behavioral biometrics are more of a continuous basis, and you can use these scores pre-post login, and you can also keep a running tally of a score of how risky the behavior of the user is. The sensor requirement for traditional biometrics is probably medium. 10 years ago, it would have been high. Today, it's probably like medium. You tend to have fingerprint readers, and on most flagship camera phones, cameras and microphones are obviously ubiquitous. But really, facial recognition might require some special cameras. So, and good fingerprint readers are also hard to find. So this is the reason it's medium. You got some consumer-grade sensors like a decent camera or microphone or some kind of a fingerprint reader. But when you really want to kind of step up, then you start paying premium prices here. For behavioral biometrics, there's really not a lot of sensor requirements. If you use the touch screen, the mouse, or keyboard. In terms of the authenticating the user, do you require explicit user action or not, right? Traditional biometrics, you actually have to do something, right? You have to look at the sensor, you have to put your finger on the fingerprint reader, you have to speak your phrase or talk to your customer support agent. So it's always an explicit requirement, which also creates the experience, right, with the user and the perception that they are being authenticated. Versus if you look at behavioral biometrics, there's no such explicit behavior. So the system continually learns behavior, continually compares behavior of a known user, and the user is actually interacting and is potentially a fraudster or account takeover suspect. The difficulty of a replay attack with traditional biometrics is usually medium. You can replay biometrics, especially if the device is jailbroken or rooted. Behavioral biometrics is really hard to replay. Although we are seeing some machine learning algorithms trying to imitate good customer behavior, it's still very difficult to actually replay, do a replay that is going to be indicative of a known good user. Functionality on day one, obviously this question refers to the length of time or length of burn-in period. Obviously with traditional biometrics, once the user provides a usable registration sample, you can compare against those samples. So it's basically once you've done that, you're good. There are some friction points in registration with traditional biometrics, obviously. Behavioral biometrics, there are some capabilities and features that you can do, but most of the functionality of the system is available basically after a burn-in period. So the system actually has to go ahead and learn the behavioral baseline of a persona or a user over a period of 3 to 4 weeks, and then things will work much better. User perception, as I said, the user feels protected with the traditional biometrics or passwords because that's what they're used to, and you have to actually do a fair bit of education of users with behavioral biometrics or continuous authentication. That you're being monitored, right? It's not that it's easy, but it's not completely unprotected. So the user experience is so easy that users basically suspect that they're not being protected. And the interaction phases for the biometrics, obviously traditionally we see login or pre-login time for traditional biometrics, and behavioral biometrics can happen pre-authentication, during login, and most importantly after authentication during the session. So definitely a very important aspect here. So you can continuously monitor the session. Some of the recommendations that we see, and based on the inquiries we take, liveness detection and privacy are key, right? So most of behavioral biometrics or passive biometrics is not an out-of-the-box solution. So these ways of authenticating users are not deterministic, right? With passwords or biometrics to some degree, you have a much higher level of deterministic deterministic processes and decisioning methods, versus with behavioral biometrics, you have to do much more tuning, and you have to basically be sure that you've done this well. So paying attention to that, as well as to performance at scale, is a very important aspect. I would only recommend using behavioral biometrics that offer liveness detection and replay prevention. So how do you make sure that somebody is not just replaying some screen mouse movements, it's not a macro, or it's not something that's replaying human behavior, or is replaying something that has happened in the past. Scalability, again, is very important. It's one thing that the solution works on a demo environment in a POC on a laptop, but when you have maybe thousands of logins per hour coming in, or login attempts coming in an hour, how the solution scales to that in terms of the mathematical model complexity and computational speed is very important. And again, getting good estimates, baseline estimates or starting point estimates in terms of false accept rates or FARs, false reject rates or FRRs, and equal error rates from solution providers is absolutely an important aspect here. So let's talk about some of our predictions, see where things are moving in this market. So again, behavioral biometrics or continuous authentication or passive biometrics is expanding to not only mobile applications and web applications, but also to phone-based transactions, call center-based transactions. Error rates obviously are further to improve. The performance improvements are really spectacular. 5-6 years ago, this was really unusable, right? Beyond a one laptop kind of demo environment, now we are seeing much more of this. Shared information used for detecting compromise patterns is also something that's very important. So if you are using a continuous or behavioral biometric solution or passive biometric solution as a software as a service offering, if the vendor and the solution provider sees suspicious behaviors or attack vectors somewhere else in their network across their customer base, they can automatically learn from those problems and apply the solution to protect your environment as well. So this is much quicker time to adequate protection than if the solution was just a purely on-prem solution. Understanding jailbreaking, rooting, and root masquerading on endpoints is very important. They're not necessarily bad things, but you have to adjust your risk strategy if you allow these devices to enter your environment, and users coming in from these types of devices enter your services. As these types of phones or these types of mobile devices can be used much easier to actually attempt to spoof or attack your passive biometrics environment. And again, integration of behavioral biometrics with payments is definitely something that we see signs of coming. Using behavioral biometrics in peer-to-peer payments as additional layers of protection is something that will elevate trust of consumers and lead to increased adoption of these payments. So definitely an important catalyst of adoption of these mobile and peer-to-peer payments. So with that, I'd like to conclude my part of today's presentation and hand it over to Ryan, who's going to talk more about NuData's offering and then further trends in the market.
No, great. Thanks, Andras. So my name's Ryan Wilk. I'm the Vice President of Customer Success with NuData Security. I'm very happy to speaking with Andras today and speaking a bit more about behavioral biometrics and some of the issues we're seeing in the industry today. So as we saw in the previous slides, the ability to authenticate your customer and know who that customer is behind the machine is becoming more and more difficult. As we see on this slide, trust is becoming somewhat of a crisis. How do we authenticate our users? How do we know who they are behind the machine? One of the problems we have today is a lot of the authentication we do is based around static data. Static data are things like the username and password, potentially a device ID. Very one-dimensional data that doesn't dynamically shift with the user, doesn't shift with the actual human sitting behind the machine. it really kind of has that on or off type thing to it, where either it matches or it doesn't match. And the problem when it doesn't match is you really lose that full visibility of who your customer is and who's behind the machine. And on top of this, the many breaches we continue to see, over 9 billion records exposed since 2013, 7 billion lost to account takeover. We continue to see the risk of this static data being out there. Bad actors are constantly out there trying to find usernames, find passwords, find credit card numbers, and they're really even starting to expand this out beyond that. Now, as we're seeing with things like the Equifax breach, we're seeing bad actors coming and getting access to really the full set of data that you need to be able to take over someone's identity, from their online persona even to their real world persona. And because of this, the taking over these accounts is becoming a bigger and bigger issue. Account takeover is one of the most costly types of fraud we're facing today. Credit card fraud still continues to be a major issue, but when you start to transition that to the account, not only do you run the risk of credit card fraud within the traditional e-commerce world, but you also run the risk of losing all of the value within that account, as well as anything that account is looking to protect. And the problem with this static data continually being breached is most of the time it's data we can't change. It's data we can't easily change, and it's the exact data we use to verify an identity. And when you can no longer trust this data, it puts you in a really difficult spot. When you think about account creation, all of that static data is the data we use to verify that identity. Can we actually trust it or not? When somebody authenticates into an account, we're looking at that username and password. If we know the usernames and passwords are breached, how do we really know it's the correct user entering that data? And then as Andres mentioned just previously, even if we do verify it's the correct user accessing the account, how do we know it's continually the correct user throughout the session as various different things change, as that user's doing different things as they're jumping from different interaction points within the session? How can we continually verify that it's not some sort of malware or not some sort of bad actor that's injected themselves into that session and is attempting to take it over? So here's the real problem with all of this, is that we talk about all this risk, we talk about all of this data being lost, but really 100% of this could be prevented, 100% of these losses could be retained. It's just, do we have the right tools in place to actually understand who our customers are and prevent the risk that we see being created? And what does that mean by the right tool? There's hundreds of tools in the marketplace, and we really have to try to pick the correct ones. I always think about this like a door. We can have many different types of doors protecting our home. We can have a screen door. We can put that up there and we can go on vacation and hope nobody jumps through the screen. Or we can get a big, thick steel vault door and put that in front of our house. Both are doors. Both do the same thing, but they protect in a very different way. So it's determining, do the tools that we have protecting the front door of our e-commerce environment, the front door of our online environment, is it actually protecting us, or do we simply have a screen door that the criminals are laughing at and they can just walk right around? We need that tool that can make intelligent decisions and do it in a very friction-free way. The more friction we put in front of our customers at authentication, Andres brought this up, I think the number was something in the 30% range. If we put a lot of friction in front of our customers, it kills conversion and it kills that ease of use of the site. If a user can't make it past the front door, they're just going to give up to start with, as opposed to even trying to do anything else. So we need to ensure it's our correct user and they're moving through the environment in a very friction-free way to give them as good of an experience as possible. So I talked about the idea of the toolbox. So you think about the toolbox at your house, the one probably sitting in your closet. There's lots of tools in there. And you have lots of tools because you need the correct tool for what you're trying to solve. If you need to hammer in that nail and you get the screwdriver, it might work eventually, but you're going to have a heck of a time with it. Just like if you're trying to put the bolt in and you get the hammer, you hit that hard enough, it might go in, but it's not going to work right. The same thing is within our digital world. We need to ensure we have the correct tools in our authentication toolbox, the correct tools in our risk-based authentication framework to really intelligently decide how we should interact with the user. If we see automation attempting to attack our authentication, what's the correct tool there? Potentially CAPTCHA could be the correct tool. If we're seeing a human come in, a human that now appears to be different, drastically different than the human we traditionally would expect to be there, potentially putting up some sort of second factor authentication, but a second factor authentication that's specifically tuned for a human. So really ensuring that you have a tool that can both intelligently determine what the risk is being presented and then intelligently trigger the correct type of step up that is most tuned to properly having that user either self-remediate themselves, so if it is the correct user that gets caught in that net, that they can very easily bypass that and continue on, or potentially if it's not the correct user, if it's some sort of risk, they get caught in that net. And it's really that idea of having the correct tools within that risk-based authentication framework that can give you the most bang for your buck in both giving your good users a fantastic experience and ensuring the bad actors are getting caught in that net. So I'm talking a little about risk-based authentication now. I know Andres went through it, and I'm bringing it up. So we have a poll now, and I think at any moment now you should be seeing a poll pop up on your screen. So I want to understand a little bit more around, do you think risk-based authentication is a good solution to detect and prevent fraud and risk? So I'm gonna move on from here, chat a little bit more while you're taking your time to answer the question, and then we'll take a look at the submissions in just a moment. So talking about risk-based authentication, is it good or is it bad? I don't think it's good or bad just in and of itself. It's only as strong as the framework you build behind it. Just like that toolbox, if your risk-based authentication may simply have a first-generation device ID player behind it, you're going to only get static information around that device. Well, it creates a little bit of value, but is it really helping you understand who that human is or lack of human behind the machine? Just like the idea of the toolbox, if you need to put that bolt in and all you have in your box is the hammer, well, you can probably make it work. You can figure it out, but it's not going to produce great results. It's going to create a lot of friction, and you're probably going to have a rough-looking whatever you were trying to put together at the end of it. Same thing if you use very basic tools around risk-based authentication, you're going to have that same problem using those kind of one-dimensional, one-layer tools. And what that really says is we need to start looking at tools that are much stronger, that look at multiple different aspects of that user's interaction, that can use that framework to really create a great result. So I see the results came in. So overwhelmingly, we got a yes that we think risk-based authentication is a good thing. So that was about 70%. We got probably at 26%, so we have some fence sitters there, and we have no at 4%. So it seems as though, well, there is somebody here who doesn't think it's a great idea. The yeses seem to overwhelmingly take this. And, again, when we talk about risk-based authentication, it's simply a framework. It's simply a structure to be able to produce a result. And it's, again, only as strong as the tools behind it. Having basic tools like device, basic tools like potentially IP recognition aren't going to give you those great results because they're going to be interdicting customers when they shouldn't, creating a high rate of friction. They're going to not be interdicting probably the people who they should be interdicting because the bad actors have figured out how to get around those one-dimensional controls. So, I think about myself, for my line of work, I travel quite often. I've been married for about a year, and my wife tells me I've been gone for about 60% of it. So I don't know if that creates a happier marriage or not, but it's kind of what it is. But because of that, I'm always in different locations around the world. My IPs are constantly changing. Being a security person, I'm extremely paranoid about any sort of security control because I know everybody's watching me. So I attempt to clear the cookies on my device as much as possible. I do things to make it difficult to track me. But the problem with this is, I try to log into my bank. And my bank has what I tend to call security theater. So, I try to log into my bank, and I log in, from the computer I always use. Even though I clear the cookies, we might lose visibility of that device ID, but I log into my bank. I do it in a way that I traditionally do. I interact the way that I always interact with my computer, and I get a pop-up saying I need to answer this 2FA question. The other day, I decided I was going to give this a test. I actually went over to the public library. I live here in Vancouver, British Columbia, so I went over to the public library. I went to my bank. I typed in my username and password, and lo and behold, I did not get the 2FA. So in my mind, that doesn't make a lot of sense. I would figure that public library computer definitely show a 2FA. Potentially computer that looks like something Ryan's always used, Ryan's behaving the way we'd expect, don't show 2FA. So the problem with that is it really creates that sense of security theater. It's a form of risk-based authentication, but what's it really doing? Is it preventing any risk? You know, based on what I see, no. So having dynamic tools that can really help raise that confidence score, using things like the passive behavior of the user. If we're simply looking at the device, looking at the connection, and not actually looking to understand that underlying human and the interaction of that underlying human, ranging from things like their passive biometric input, going to things like their overall behavior, and we'll talk about that more in just a bit, you're really just going to have that one-dimensional look at the user, and you're not going to be able to get to that next layer and really dynamically authenticate the human versus simply trying to verify that my MacBook appears to be a happy MacBook that we should allow in. So that continues to move on to the idea of an integrated solution. So we talk about all of these different pieces, you know, and I know I kept putting down device, but device still does have a lot of values. So you know, I'll be bipolar for a moment. But we have device, we have things like IP, we have passive biometrics, we have all of these different tools, but we now need to not just use them in a one-off situation, we need to use them dynamically. We need to ensure that all of these different tools are integrated and are intelligently working and intelligently helping us understand when risk is occurring. So, you know, just as I was talking about with my bank, you know, if I come on and I appear to be Ryan, why is that bank interdicting me? Its RBA framework is looking at some very basic, very static data. You know, I look to you know, banks and e-commerce companies need to really start using a more dynamic sense in how they do this, looking to understand, are there thresholds of what my behavior looks like that now allows me to be known, as opposed to when I fall below certain thresholds, intelligently stepping me up. And then also, underneath this intelligence, using an intelligent set of two-factor authentication. You know, I'll throw a little plug out there for a second. You know, my parent company, MasterCard, offers a really great product called Identity Check Mobile. But again, these tools are really great in being able to be used once you have that intelligence, once you have that really intelligent framework, being able to tell you what is occurring, what is the risk, what is the lack of risk, and then allowing these other tools, these 2FA tools, to step you up and help to better understand, is it the user or is it not the user. So here's just a little example from some data within new data. So, you know, I think this example might be a little extreme, but I think it really highlights what one-dimensional static data does. So in the past month, new data saw out of logins, out of everyone that logged in within the NewDetect platform, there were 17 million logins that had an IP address that had never been linked to that user before. So if we're simply trying to say the user's coming on a different IP address, step them up, you know, that 17 million logins we're now going to step up. That does not sound like a great customer experience to me. If we then layer over behavioral data, so looking at that user, looking to say, are they behaving and interacting in a way we would expect based on all historical interactions from this user, we're able to very quickly eliminate over 80% of that bucket. So saying that, well, they're all on a new IP, they're all, you know, coming in on a new static data point, we're able to passively verify it's the correct user, giving all of those users a much better experience than if you just take that one static data point. Now, if you start to expand that out kind of on those integrated layers that we just talked about a moment ago, you can even start to shrink down that 20% and what you might have called that 20% of high risk now starts to shrink down to, you know, 1%, maybe less than 1%. Falls within what truly is high risk in your environment and not just triggering based on very static data points that really, in the end of the day, mean nothing about risk or nothing about validity, just simply showing that things changed. You know, this really plays into kind of the ideas of the real world as well. Understanding, you know, the folks around you, understanding who you're interacting with. I always use this idea of a red shirt and a blue shirt. You know, most of us aren't cartoon characters, so we change our clothes every day, and we have different versions of our clothes, fortunately. So, you know, I look at my various colleagues, And just because my colleague is wearing a red shirt today versus a blue shirt, I don't lose all visibility to who that person is. I know the underlying human, I understand the underlying human, and I can interact with them as the person I know, regardless if their shirt, we can say the shirt is kind of equivalent to a device, changes, we don't lose complete visibility. And that's what having this dynamic framework gives you, the ability to really understand the user even as various aspects of them are changing. So, it really, I think I've mentioned this a couple of times now, but really that idea of looking at the human. We need to stop looking at the device, stop looking at the IP, stop looking at all this static data, and looking at what interactions, what various things about the interaction makes up that human, makes up the person we're actually expecting to be behind the machine. And when we can actually understand if it's the correct human, we can weed out the bad users and give the good user a better experience. We go back to that example of the door, and we can make it even smarter now. Okay, we have our screen door, we have our vault door, but how about we get rid of all the doors and we put a person sitting there in a chair looking at everyone coming in, verifying. Now that we've taken it a step deeper, we're not just simply trying to block people, we're actually looking to say, do I understand this person? Do I understand the person that's coming through this door? Does this person appear that they should be coming through the door? And we can become extremely intelligent around how we're verifying people, how we're understanding who they are before they ever get past that initial point of entry. So I have another poll now. This one is a little bit different. So the question is, how familiar are you with behavioral biometrics? So I think, again, the poll should have just popped up there. A couple different options. I'm going to keep moving on as you have a chance to answer it, and then we'll chat some more about this in a couple minutes. What I would like to chat about now, though, is some of the results that NuData has seen being able to use intelligent step-ups, intelligent risk-based authentication with some of our clients in the real world. So this is a large bank that we work with in the United Kingdom. This bank had been using, or is using various types of step-up techniques, including card and reader as well as tokens. So we all know from work, back in, we might have switched over to soft tokens nowadays, but we all remember having that RSA token dangling from our keychain. And every time we log into our computer, we need to pull that out and log in. We can somewhat understand that for our corporate network. We're trying to keep it extremely secure. But when you start to look at more consumer-oriented things like a bank account, you might want to be able to get into that bank account and not always have to know where your token is, not always have to have that hardware to be able to do that card reader verification. So this bank wanted to better understand how they could passively verify their users, understand it was the correct human behind the machine, allow them to authenticate through without having to use card and reader for every single event, and give them a much better frictionless experience. We found with this bank that on a regular basis, we can passively verify over 91% of the user environment. This obviously kind of ebbs and flows depending on the amount of new users, and as Andres was saying, there's a certain level of enrollment. But when you can start to think that you can passively know that 91% of your environment is the correct human sitting behind that machine, is the correct person that's not going to create risk, first off, you can let them through that authentication point in a friction-free manner. And then risk-based authentication really kind of evolves beyond that. It evolves from simply deciding, should I allow this person in or should I not allow them in? But now that I know it's them from that front door, I can modify the entire experience once they get beyond the front door. I can give them a lower friction through checkout. I can remove high friction checkout techniques that might be killing conversion. I can ensure that we're not going to have those username and password problems, seeing 30% of conversions drop off before they even make it through the front door. I can offer better shipping methods. I can offer different products that you might never have dreamed to offer online, or your kooky sales and marketing department want to put up there. And you would say, why in the world would we ever do that? You can facilitate those things. You can become a facilitator of sales within your company, as opposed to just trying to inhibit risk. Now, vice versa, and I think this is something to think about as well when you're talking about risk-based authentication, is ensuring that your risk-based authentication tool is not just looking for risk. Lack of risk is an identification of risk as well. When you can say there is no risk, that is a risk level. It is a lack of risk level, and you can give that user a better experience, really weed out all of that noise, so you can ensure that you're giving the good users a good experience. And as we see here, a large e-commerce company that NuData is working with that had a large ATO problem, they were trying to determine, is it really my good user or is this ATO, and trying to really weed out that noise. So, doing both of those things at the same time becomes extremely important. So NuData worked with this company, found after implementation that nearly 50% of all of their authentication attempts were ATO attempts. Now, huge problems in multiple, directions. First off, we have the generalized risk of what somebody getting through as an ATO could create. But then on top of that, we start to see that there's lots of problems around, the infrastructure behind this. If 50% of your authentication attempts are bad actors, you're having to build up your authentication infrastructure to be able to support all of those calls. So you're now having the risk of bad actors taking over accounts, as well as the risk bad actors are creating to your infrastructure costs that you need to build up all that infrastructure. So having that full visibility of, is it my good user at authentication, or is potentially this user creating risk either through automated ATO or through one-off human ATO, gives you that huge step up in being able to really understand who's behind the machine. So I see the results have come in around are you familiar with behavioral biometrics? So we see that there's only about 3% that's at extremely, and that's good for me because my next slide then lets me talk about it. We see that for that between mildly and intermediate, there's a majority, and then about 10% are saying they're not too familiar with it. So let's take a little bit of time to now be a little bit more familiar with behavioral biometrics. So talking about NuData's approach to how we look at behavioral biometrics and how we look at the user behind the machine. We look at this as needing to understand all of the different aspects that make up that user's digital interaction identity. As I was mentioning, just like in the real world, you have lots of different things that make up how you interact. You might go to a coffee shop every day. That barista recognizes you. They know the type of drink you order. They know what you look like. They probably know your name because you give it a certain name that's on the cup. But do they really know who you are? Well, no, they don't know your social security number. They don't know potentially the type of car you drive. They don't know your wife's name, your husband's name. They don't know where you live, but they know a lot about you. They know a lot about the persona that makes up you. NuData looks to understand those same things within the digital world, ranging across 4 core layers of behavioral interaction. The first being device connection and location, looking to understand how the user's entering the environment, what device they're using to interact with it, and what's the connection they're using to actually tunnel through. Very similar, how you get to work every day. What's the car you drive and what's the path you take to get there? The second layer NuData looks at is behavioral analytics. So we look at behavioral analytics on 2 different levels. The first being the individual user layer, so understanding what each time Ryan returns to the environment, is Ryan behaving the way we'd expect Ryan to behave? Is he using the same types of devices we'd expect him to use? Is he interacting, say, in his bank account? Is he doing things that we've traditionally seen him do within his bank account? All of a sudden, if I'm transferring every cent out of my account maybe to Russia, that would be something that is unusual for Ryan's behavior. We then look at the full population to understand the hundreds of data points being collected, how they all exist in relation to one another, looking to understand if there's any sort of statistical outliers, any sort of deviation that's starting to create a subpopulation that we can then better understand why is that subpopulation existing, is that subpopulation creating risk, or is that subpopulation potentially a valid subpopulation, or is the entire environment kind of ebbing and flowing the way we would expect? The third layer we look at is passive biometrics. And passive biometrics really looks to understand how the user's interacting with the device. So one of the things Andras was mentioning earlier was your solution really needs to have an understanding of liveliness. Is the actual device being interacted with? Is it not being interacted with? What we can do with this is we can understand, first off, the way that the user is actually holding the device. Are they holding it in a right-handed configuration, left-handed configuration? Are they inputting, first off, is it a human or is it not a human based on that interaction? Secondly, based on how they're actually interacting, based on their profile, is it the same human we've seen historically? Is it the same human we've seen time and time again? Not just understanding is it the same device connection, location, and behavior, but is it actually the same human? And finally, wrapping that within our real-time trust consortium, NuData having processed over 200 billion behavioral events in 2017, being able to bring all of that learning, all of that real-time learning together and doing it at massive scale to really be able to create value for our clients and being able to use data across our entire cloud infrastructure to better understand when threats are emerging throughout the ecosystem. And then finally, to close up the presentation before we jump into a couple questions, I think the thing that we really need to take away from here is that RBA is still an extremely valuable framework, but it's only as valuable as the tools underneath that framework. And those tools really need to shift away from looking at static data like the device, static data like the IP address, and really look at dynamic information that helps us understand who that human is and who that human is on the other side of the machine, as opposed to simply trying to verify the device. And it really goes back to that idea of the red shirt and the green shirt. Do I lose visibility to my user just because they change small little aspects of themselves? Or do I have a really strong understanding of who my user is, what their behavior is, what their interaction techniques are like? So even as those subtle things change, I can really understand those unique and unchangeable, non-spoofable aspects of my human user and provide them with a fantastic experience and really drive more conversion and drive more value to my web property. So thank you. Appreciate everyone's time. Let's open it up for some questions. Okay, so I know there's I do see in the Q&A there are a few questions here. One of the questions that I have is how long does it take to implement a solution like this and really create value? Implementation is quite easy. It involves a little bit of code on the client browser or the client app where we're integrating, and I think that a good thing to point out is that behavioral biometrics are extremely powerful today within the web, API, and native app environments, really being able to understand the user across multiple different interaction points. So from an integration standpoint, it's a little bit of code in the client browser, the client app, an API call from the application server, and you're pretty much good to go. Once you're fully set up, certain types of use cases can be solved immediately. Population level use cases to understand things like automation, population deviations, can identify those from day one. Some things that look to understand the individual human users to say, is this the correct human I'm expecting, can take a little bit longer. You traditionally need to see them anywhere from 5 to 10 interactions to be able to have enough information to build out a profile around them to really understand who that user is.
I have another question here. We'll transition, and that's Andras talked a couple of times about performance at scale. So Ryan, it seemed from your case studies you do scale. What are you seeing in regards to addressing scale with behavioral biometrics?
I think that when you're talking to any behavioral biometrics provider, you need to ensure first off that they actually have scale within an environment, within a customer environment. Many of the solutions out there today, they all look great. It's extremely important to find out, do you have any customers and are you doing this at scale? One of the questions we quite often get is how fast can you process data? And it's a good important question because with behavioral biometrics, you're really looking to move just beyond the checkout, just beyond the transaction where a lot of this traditionally lives. You're moving up forward, you're moving into the authentication stream, you're moving into the new account creation stream. And in those places, a lot of the experience teams at e-commerce companies or at banks become much more concerned about latency, around how long does this actually take? Is there going to be a blocker for my user's experience? You're always fighting that battle of, I want a good user experience, but I want security. And unfortunately, quite often it seems that user experience wins out over security. So really ensuring that the solution you're picking does this at scale, can handle huge volumes. I think another thing a lot of people don't think about when they're implementing one of these solutions at login is that, you look at your valid logins, but are you also looking at your failed logins? Are you looking at any ATO attacks that might be occurring? Quite often, the volume hitting your login is significantly higher than you even knew or that you're currently expecting it to be. Because of that, you need to ensure that the tool that you're selecting can handle data at scale, has a proven track record of handling data at scale, and if it doesn't, you can go for it, but and make sure that you're understanding that you're putting something in line in your user experience, and that it needs to be able to handle the load of data that's being sent to it, and it needs to do that reliably.
Okay, we have a question perhaps that Andras can cover here. And what is the integration method for these types of services?
Sure. That the integration methods are relatively easy. Most behavioral passive biometrics requires some level of for web applications, some JavaScript to be run on the client browser, and obviously this JavaScript has to be served from the server, so that's that. And in many cases, you use SDKs for native mobile application integration. So you get a vendor's SDK, you kind of compile the application with that, and that takes care of some of these things. Beyond that, obviously, you want to do some level of single sign-on architecture as well for traditional authentication and integrate behavioral or passive biometrics with that, as well as with risk-based methods. So maybe Ryan has some ideas here as well.
So we have another question here. It says, I am working within a gaming company where we have a huge amount of data, but we struggle to identify a system which could help us analyze all this. We are looking for a machine learning solution. However, most of the customer information is based on declarative, and I'm not sure how that cut off, but it says, how could we deal with this?
So from a scale standpoint, like I was mentioning, NuData works with some of the largest companies in the world, having processed, and this is all in real time, having processed over 200 billion individual events. So I call them a behavioral event. NuData processes or analyzes data at different touch points. So you can kind of think about that as NuData processed over 200 billion logins last year. So scale of data is something we can definitely handle. And as far as it can, I'm just looking at analyze. So from a machine learning standpoint, I wouldn't see a problem with the scale. Depending on what the use cases are, we'd have to better understand that, just because the question doesn't exactly get into that. But using all of the information collected around the user's behavior, that wouldn't be a problem within our framework.
Okay, it looks like we have time here for another question. So do you see this user behavior monitoring as more and more important in the modern connected world, especially with the authentication points on multiple devices?
So I would say yes, and I'd say that the multiple devices point is very important. You think about most people, most people have at least two devices. So they have their computer and they have their phone, which for lack of better words is a computer nowadays. And then most people expand that out. They have their work computer, they have their home computer, they might have two home computers. The family has phones. There's probably a couple tablets laying around. It's amazing how many devices that you could probably go and gather up within your home, and you probably blow your mind some of the ones that you didn't even realize that you were using as coasters. But being able to understand the full array of device types that are linked back to a user is extremely important, and how they interact on those device types. NuData builds out profiles based around user interaction, but is specifically user interaction on different styles of devices. So how does a user interact on a keyboard? So whether that be kind of a mechanical keyboard in front of a desktop computer, the keyboard on a notebook computer, looking to build out profiles around how a user interacts on kind of an iPhone or a Samsung phone style interaction, or even on a tablet. By being able to understand the device types that a user traditionally interacts on, the times of day they traditionally interact on those devices. During the workday, you're usually on your work computer. Once you get home, you usually transition to your home computer. There's a high likelihood we'll see you on your phone all day long, probably into the wee hours of the morning, into the wee hours of the evening. So by understanding the set of devices that user interacts on, how they interact on those devices, being able to have that full knowledge built into a user's profile so that as that user's coming in, you can make a very intelligent decision, not just around the interaction, but even around how they're interacting on the specific device type. And if that specific device type makes sense for that user at that point in time, gives you a much better breadth around how authentication works. And then really being able to even expand that out into different types of authentication. Does that user use Touch ID? If they're always using Touch ID and then you see them not use Touch ID, is that a deviation? Is that something that you can now dig into and better understand? So I think that, you know, if you have all of your different devices and all your different authentication techniques all streaming in the air like streamers, you know, you're going to have a hard time understanding how it all fits together. But if you have one intelligent framework that can bring that all together and really understand, you know, how all of that relates back to the user and the user's behavior, it just becomes another way to really authenticate and another way to understand is your user behaving in the way you'd expect them to.
Okay, terrific. So we have a lot of great questions that have come in today, but we are at the top of the hour. So just want to let everybody know that we will respond to you back via email following the presentation. We'd like to thank you for your attendance today. On your way out of the event, you will be taken to a post-event survey. We do appreciate your perspective, so if you take a moment to respond to our survey, we'd greatly appreciate it. Again, thank you to Ryan and to Andras, and on behalf of New Data Security, we thank you again for your attendance today. This concludes our webinar. You may now disconnect.